Hey there, Joel here and welcome to my channel Math World. Today we are going to solve and learn trigonometric identities, and I'm sure you will be wondering what are these trigonometric identities. Trigonometric identities are nothing but an equation which is true for all the cases. Now, the moment I say an equation, that means there should be an equal to sign. Now on the screen, you can see three different identities and all of them have an equal to sign in between somewhere, right? So it tells you that whatever value of that theta or the angle that you take, if you put them in this condition, then the left hand side and right hand side will be true always. Okay, that's the meaning of an identity, or in the simplest form, if you want to understand, identity is nothing but a formula which is true for all cases. Okay, what you can see in front of your screen right now are Pythagorean identities. That means they are true only for right angle triangles. And I've told you in the introductory video of Introduction to Trigonometry that in your SSC 10th standard curriculum, we are focusing more on right angle triangles and not any other triangles. Okay, so currently you need to learn these three identities. Sin²Ɵ plus Cos²Ҭ is equal to 1. 1 plus tan²Ҭ is equal to sec²Ҭ. 1 plus cot²Ҭ is equal to cosec²Ҭ. Okay, now whenever we are going to solve problems later on, these identities have to be, like in your mind very clear. You can't fumble with these identities. That's the reason I've kept them on the screen for a while. Learn them, but it doesn't make sense, learning something which you don't understand. How are you even getting it? So what we are going to do is we'll solve the first identity, that is sin²Ҭ plus cos²Ҭ is equal to 1. Let us understand how exactly we get this identity. All right, so let's go ahead. So in a right angle triangle, for some angle A is equal to theta, prove that sin²Ҭ plus cos²Ҭ is equal to 1. So what we'll do is we'll draw one triangle over here and name it ABC. Now since my angle A is theta, let me mark it theta over there. Right? For those who don't know, theta is a Greek symbol used for angles. All right. Now by Pythagoras theorem, I can write AC square is equal to AB square plus BC square. That is the Pythagoras theorem. If you have not watched videos for Pythagoras theorem, I'll link it down in the description box. It's part of triangles chapter. All right, so he says that hypotenuse square is equal to sum of the other two sides. That's how I got. So in the next step, what we will do is we'll take this theorem of Pythagoras and divide it with AC square. Okay, so dividing the above equation by AC square, we get, now you'll have to divide it in all the three terms throughout the equation, because you can't divide it only in one place. So AC square upon AC square will be 1. Let us understand what will happen to AB square upon AC square. For a moment, forget that square, okay, and look at the triangle ABC. You are looking from angle theta. Now on the right hand side, you can see some formulas now which you have already learned in the previous videos. If you have not watched those videos, please take a look at them, because you have to learn them, for these formulas, to go ahead and solve these identities as well. Okay, so from the angle theta, if I'm looking, AB is next to the angle, so it will be called as adjacent, and AC, which is green in color, is the hypotenuse. So which is that trigonometric function which is relating adjacent and hypotenuse? If you look at it on the right hand side, it is cos. So since there is AB square upon AC square, I can write it as cos²Ҭ. That is how we got it, right? So AB square upon AC square will be cos square theta. If it was just AB upon AC, I would write it as cos theta. Since there is a square, I'll have to put cos square theta. Similarly, let us see what happens when you look from angle theta to BC square upon AC square. So again, focus your eyes on the triangle ABC and look at BC. So here BC is nothing but, which is in purplish color, which is opposite, and AC is the hypotenuse. Trigonometric function that is relating opposite and hypotenuse is sine, and since there is a square, I'll have to write sine square theta. So therefore, if you look at the second step again, AC square upon AC square will become 1, and the other functions will become cos square theta plus sine square theta. And just by rearranging them according to how we want to prove them, it is sine square theta plus cos square theta is equal to 1. I hope this identity is very clear. Sometimes this is asked to prove for exam, but you need to know the identity well. Sine square theta plus cos square theta is equal to 1. At times on the books or some learning materials, you might get, instead of that theta, they might write a. So you might have the identity as sine square a plus cos square a is equal to 1. It's the same thing. It's nothing different. So I prefer you learning it as theta, because it become, the sound makes it very easy to learn. So sine square theta plus cos square theta is equal to 1. I hope you have understood this entire identity. If you did, please don't forget to hit the like button, share the video with your friends, and subscribe to the channel so that you don't miss out any more updates. Thank you and God bless you.